Hello, welcome to Dheeraj Academy. I am Manisha, the maths tutor, and today we will learn about the Euclid's division lemma. So, what is the Euclid's division lemma? Basically, it's nothing but related to the division. Yeah, so division help us to understand that how numbers relate to each other. Yeah, so division is basically the process of splitting or dividing a number into the equal parts. Yeah, so the Euclid's lemma statement is the formula is our the A equals to BQ plus R. So what is the A? A is the here dividend. Yeah, so this dividend is basically the number which is divided. So the number which is being divided, we call it as the dividend. And the B is your the divisor. The number by which we divide, we call it as the divisor. The next is our the quotient. Yeah, the number of groups or the result of division is our the quotient. And the remainder, that is the whatever left over, we call it as the remainder. So the Euclid's division lemma is the A equals to BQ plus R. That means your dividend equals to the divisor into quotient plus remainder. So here we have the one example, 7 division 5. So how we can apply the here the Euclid's division lemma. So the dividend is the A here. So A is minus 17 here. Yeah, A is 17, B is minus 5, and the quotient is our the here we have to make how many groups we can make the complete groups. That will be the quotient. And the remainder that will be the leftover. Yeah. So here the 17 when we divide it by 5 we get the 3 complete groups. Yeah. And the 2 remainder. So this is the form of the Euclid's division lemma. So another example is 23 division 4. So 23 is the total count here and we have to make it of the group size that is the 4 and how many groups complete groups can we make from it that is the 5. Yeah, and the remainder that we left over is your 3. So according to the Euclid's division lemma 23 equals to 4 times 5 plus 3. So there is a special case that is the zero remainder. Yeah. So remainder 0. In the previous example, there was some remainder left over, but sometimes the number is completely divided by the divisor and the remainder is 0. So we call it as the zero remainder. Yeah. So like over here, the 20, when divided by 5, it gives us the remainder 0. So here dividend is 20, divisor is 5, quotient will be your 4 and remainder is 0. So this is the case of the exact division. Yeah. So here no leftover is left. The number is completely divided. Now where we use this Euclid's division lemma? We use it in finding the HCF. This is the main application or major application of this Euclid's division lemma. So how we find the HCF? We have to start with the two numbers. So take the larger number as A and smaller number as B. And we have to apply this division lemma. So A equals to BQ plus R. We have to put it in this format and we have to repeat this process until we get the R equals to 0. So we can understand this by using one example. So we will see that how we can find the HCF of 48 and 18. So here our 48 we will consider it as A and 18 is the smaller number that we will consider as B, and how many groups of the 18 can be made in 48? So we can make the two groups of 18 in 48. So we will do it 18 times 2 plus whatever the leftover is 12. In the next step, we will make this remainder as the divisor. So this will become our now the divisor will become the 12 and the 18, the previous divisor will become the 8. Now how many groups of 12 we can make in 18? That is 1 and remainder will be the 6. Now again we will make this 6 as the divisor and the 12 as the our dividend. So in this way, we interchange the divisor and dividend until the remainder comes 0. When the remainder comes 0, this divisor 6 is our the HCF. So this will be the HCF. So in this way, we can find the HCF easily by using the Euclid's division lemma. So what is the common mistakes which is mostly done? So this is the wrong remainder. Yeah, sometimes the students do the greater remainder, take the remainder greater than divisor or equal to the divisor. So always check that the remainder should be greater than 0 and less, maybe greater than or equal to 0, but it should be less than the divisor. So this condition is crucial, yeah, very, very important. Without it, the lemma does not hold true. If the our remainder becomes negative, then the division will not, the Euclid's lemma will not work properly. Ignoring uniqueness, so that the quotient and remainder are unique here. Yeah, so there's only one correct answer for this. And lemma applies only to the positive integers. So be careful with the negative integers. So this is about the Euclid's division lemma. Yeah. So we have learned about the Euclid's division lemma, which is basically used to find the HCF, LCM, and number theory. So if you find this video helpful, then please subscribe to the Dheeraj Academy. And if you like it, please subscribe it and thank you.